Mercury is the closest planet to the Sun and the smallest planet in our solar system. It is named after the Roman messenger god, Mercury. The planet has a diameter of about 4,880 kilometers, making it slightly larger than Earth's moon. Like the moon, Mercury's surface is covered with many craters because it does not have a significant atmosphere to burn up meteoroids before they strike the surface. Some of these craters are extremely large, with the biggest being the Caloris Basin, which stretches about 1,550 kilometers in diameter. Despite its small size, Mercury is the second densest planet in the solar system after Earth. This is due to its unusually large iron core, which makes up nearly 85% of the planet's radius. Surrounding this core is a relatively thin silicate mantle and crust. This unusual internal structure has puzzled scientists for many years. One theory suggests that Mercury may once have been a larger planet, but a massive ancient collision stripped away much of its outer layers, leaving behind a disproportionately large core. Mercury also has the most eccentric orbit of any planet in the solar system. This means its distance from the Sun changes greatly during its orbit. At its closest point, Mercury is about 40.6 million kilometers from the Sun, while at its farthest point, it is around 70 million kilometers away. Another unique feature of Mercury is its slow rotation compared to its orbital period. It takes about 59 Earth days to complete one rotation on its axis, while it completes one orbit around the Sun in 88 Earth days. Because of this, a single day on Mercury, from one sunrise to the next, lasts about 176 Earth days. Since Mercury is so close to the Sun and lacks a thick atmosphere to retain heat, it experiences some of the most extreme temperature changes in the solar system. During the daytime, surface temperatures can rise to about 430 degrees Celsius, while at night they can drop to around -180 degrees Celsius. Studying Mercury has always been challenging because of its proximity to the Sun, which makes it difficult to observe from Earth. Only a few spacecraft have visited the planet. NASA's Mariner 10 was the first mission to fly by Mercury in the 1970s, capturing the first close-up images of its surface. More recently, NASA's Messenger spacecraft orbited Mercury from 2011 to 2015 and created detailed maps of the planet's surface. One of its most important discoveries was the confirmation of water ice in permanently shadowed craters at Mercury's poles. Because Mercury has a very small axial tilt, some craters near the poles never receive sunlight. These regions remain extremely cold, allowing ice to exist despite the planet's intense daytime heat. The presence of water ice on Mercury suggests that volatile materials, such as water, may have been delivered to the planet by comets. Although Mercury is small, it provides valuable clues about the early formation of the solar system and the processes that shape the terrestrial planets. Future missions, such as the European Space Agency's Bepicolombo spacecraft, will continue exploring Mercury, helping scientists learn more about its composition, history, and role in the solar system. Venus, often called Earth's sister planet because of its similar size and mass, is one of the most fascinating yet hostile worlds in our solar system. It is the second planet from the Sun and the brightest object in the night sky after the Moon. Venus has a diameter of about 12,104 kilometers, making it only slightly smaller than Earth. Its surface is rocky and covered with plains and volcanoes. In fact, Venus has more volcanoes than any other planet in the solar system, with over 1,600 known volcanic structures. One of the most unusual characteristics of Venus is its slow retrograde rotation. It takes about 243 Earth days to complete one rotation on its axis, which is even longer than its year. This means that a single day on Venus lasts longer than an entire Venusian year. Additionally, Venus rotates in the opposite direction compared to most planets, so the Sun rises in the west and sets in the east. Venus is well known for its thick and toxic atmosphere, which is composed mostly of carbon dioxide, with traces of nitrogen and clouds of sulfuric acid. This dense atmosphere causes an extreme runaway greenhouse effect that traps heat very efficiently, making Venus the hottest planet in the solar system. Surface temperatures average around 465 degrees Celsius, and these intense temperatures remain nearly constant across the planet, even during nighttime. Another extreme feature of Venus is its surface pressure. The atmospheric pressure on Venus is about 92 times greater than Earth's sea level pressure. This is equivalent to the pressure found nearly 1 kilometer underwater on Earth, making Venus's surface an extremely hostile environment for landing missions or machinery. The first spacecraft to visit Venus was NASA's Mariner 2 in 1962. The Soviet Union also achieved major success with its Venera program, which landed several probes on Venus's surface. These missions sent back the first images from the planet's surface in the 1970s, although the harsh conditions quickly destroyed the probes. Later, NASA's Magellan mission in the 1990s produced detailed radar maps of Venus's surface, revealing its complex and geologically active landscape. Although Venus is currently dry and lifeless, there is evidence suggesting it may have had water in its distant past. Some scientists believe that billions of years ago, Venus may have had Earth-like conditions, with oceans and a milder climate. However, due to a runaway greenhouse effect, the planet eventually lost its water and experienced extreme surface heating. In recent years, interest in Venus has increased after the detection of phosphine in its clouds, a potential biomarker that could suggest microbial life in the more temperate layers of Venus's atmosphere. This discovery is still being investigated, and further missions are planned to explore this possibility. Despite its extreme conditions, Venus provides valuable insights into planetary evolution, climate change, and the effects of a runaway greenhouse process. As more missions are planned to explore Venus, scientists hope to uncover secrets about its past and better understand how Earth's sister planet followed such a different path in its development. Earth, the third planet from the Sun, is the only known planet in the universe that supports life. With a radius of about 6,371 kilometers, Earth is unique because of its complex ecosystems, atmosphere, hydrological cycle, and active geophysical processes. Our planet formed approximately 4.5 billion years ago from the solar nebula, a massive cloud of gas and dust that gave birth to the solar system. Over time, gravity pulled materials together, forming Earth's core, mantle, and crust. The core consists of a solid inner section mainly made of iron and nickel, and a liquid outer layer that generates Earth's magnetic field. Above the core lies the mantle, composed mostly of silicate minerals, which accounts for about 84% of Earth's total volume. The outermost layer, the crust, is thin and divided into tectonic plates that float on the more fluid mantle. Their movement causes continental drift, earthquakes, and volcanic activity. Earth's atmosphere is a thin yet essential layer of gases surrounding the planet. It is made up of about 78% nitrogen, 21% oxygen, and small amounts of other gases such as carbon dioxide and water vapor. This mixture is vital for supporting life, as oxygen is needed for respiration and carbon dioxide is necessary for photosynthesis in plants. The atmosphere is divided into layers, with the troposphere closest to the surface, where weather occurs. Above it is the stratosphere, which contains the ozone layer that protects life by blocking harmful ultraviolet radiation. Higher layers include the mesosphere, thermosphere, and exosphere, each having specific roles such as shielding Earth from meteoroids and helping regulate temperature. The crust is broken into several large and small tectonic plates that are constantly moving due to heat from Earth's interior. This plate movement produces various geophysical events, including mountain formation, earthquakes, and volcanic eruptions. Humans have lived and evolved on Earth for hundreds of thousands of years, shaping ecosystems and landscapes in significant ways. Through agriculture, industry, and technology, humanity has built advanced civilizations. However, this progress has also created serious challenges, including environmental degradation, pollution, deforestation, and loss of biodiversity. In recent decades, people have become more aware of their impact on Earth and have started taking steps to reduce damage through conservation efforts, sustainable development, and actions to combat climate change. Understanding and protecting Earth's complex systems is essential to maintaining the delicate balance that supports all forms of life. Mars, often referred to as the Red Planet, is the fourth planet from the Sun. It has captured human imagination for centuries because of its potential to harbor life, its similarities to Earth, and the possibility of future human exploration. Mars is a cold, desert-like world and is home to the largest volcano and the deepest canyon in the entire solar system. Because of these features and its potential for life, it remains a prime target for scientific research. Mars is roughly half the size of Earth, with a diameter of about 6,779 kilometers. Despite being smaller than Earth, its total surface area is nearly equal to all of Earth's land masses combined, mainly because Mars does not have oceans. The planet's reddish color comes from iron oxide, or rust, that covers much of its surface. Mars has a very thin atmosphere made mostly of carbon dioxide, with small amounts of nitrogen and water vapor. Because this atmosphere is so thin, Mars cannot retain much heat, leading to extreme temperature changes. Temperatures can reach about 20 degrees Celsius near the equator during the day and drop as low as -153 degrees Celsius at the poles during the night. Mars experiences seasons similar to Earth due to its axial tilt, but they last longer because Mars takes about 687 Earth days to complete one orbit around the Sun. A day on Mars, known as a sol, is slightly longer than an Earth day, lasting about 24.6 hours. The planet has two small and irregularly shaped moons, Phobos and Deimos, both much smaller than Earth's moon. Scientists believe these moons are captured asteroids from the asteroid belt between Mars and Jupiter. Phobos, the larger moon, is slowly moving closer to Mars and is expected to either crash into the planet or break apart to form a ring system in about 50 million years. Mars also features vast plains, valleys, and polar ice caps made of both water ice and frozen carbon dioxide. Although Mars is cold and dry today, scientists believe it was once much warmer and wetter, with a thicker atmosphere capable of supporting liquid water on its surface. There is strong evidence that rivers, lakes, and possibly oceans existed on Mars billions of years ago. This evidence comes from images of dried riverbeds, sedimentary rock formations, and minerals that only form in the presence of water. In recent years, missions such as NASA's Curiosity and Perseverance rovers have explored Mars's surface in search of signs of ancient life. These missions have discovered organic molecules, though they are not yet definitive proof of life. The next major step in Mars exploration will be human missions. NASA and private companies like SpaceX are working towards sending astronauts to Mars in the 2030s. These missions will be crucial in determining whether Mars could become a future home for humans. As technology advances, the red planet may provide answers to some of humanity's most profound questions about the origins of life and the future of space exploration. Jupiter, the largest planet in the solar system, is the fifth planet from the Sun and contains more than twice the mass of all the other planets combined. As a gas giant, it does not have a solid surface, and its atmosphere is mainly composed of hydrogen and helium. Jupiter has a diameter of nearly 143,000 kilometers, making it more than 11 times wider than Earth. In fact, more than 1,300 Earths could fit inside Jupiter. Despite its enormous size, Jupiter has a relatively low density because it is made mostly of light gases, primarily hydrogen and helium. Similar to the Sun, scientists believe Jupiter may also have a dense rocky core about the size of Earth, although this is still being studied. Jupiter's atmosphere is one of its most fascinating features. It displays alternating light and dark bands running parallel to its equator. These bands consist of clouds made of ammonia crystals. The lighter zones are higher and cooler, while the darker belts are lower and warmer. Jupiter's complex weather patterns are driven by its rapid rotation, internal heat, and high-speed winds that can reach up to about 500 kilometers per hour. The planet is home to some of the most powerful storms in the solar system, the most famous being the Great Red Spot. This massive storm has been active for at least 350 years and is about 1.3 times the size of Earth. It is easily visible from space, although recent observations suggest it has been shrinking over the past few decades. Jupiter has the strongest magnetic field of any planet in the solar system, about 20,000 times stronger than Earth's. This powerful magnetic field creates an enormous magnetosphere that extends millions of kilometers into space, protecting Jupiter and its moons from the solar wind. The magnetosphere also traps high-energy particles, producing intense radiation belts around the planet. Jupiter also has a faint ring system made mainly of dust particles ejected from its moons during impacts. Unlike Saturn's bright icy rings, Jupiter's rings are darker and more difficult to observe. They are composed mostly of microscopic dust grains that are continuously replenished by material knocked off its moons by meteorite impacts. One of the most remarkable features of Jupiter is its large system of moons. As of 2023, Jupiter has 95 known moons. The four largest moons, called the Galilean moons, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in 1610. These moons are among the most studied objects in the solar system. The potential for life, especially on Europa, has made the Galilean moons a major focus of future space missions, including NASA's upcoming Europa Clipper mission and the European Space Agency's JUICE mission. As future missions continue to explore this giant planet, Jupiter will remain a central focus of planetary science for many decades to come. Saturn, the sixth planet from the Sun, is the second largest planet in the solar system and is best known for its spectacular ring system. As a gas giant, Saturn is similar to Jupiter but is distinguished by its lower density and its complex system of rings and moons. Saturn has a diameter of about 120,000 kilometers, making it roughly 9 times wider than Earth. Despite its enormous size, it is the least dense planet in the solar system, with a density lower than water, meaning it would float if placed in a body of water large enough. Saturn's low density is due to its composition, which is mostly hydrogen and helium. Scientists believe Saturn has a small rocky core surrounded by a thick layer of metallic hydrogen, which gradually transitions into liquid hydrogen and helium as pressure decreases toward the outer layers. Saturn's rapid rotation causes it to bulge at the equator and flatten at the poles. The planet's upper cloud layers are mainly composed of ammonia ice, while deeper layers contain water ice and ammonium hydrosulfide. Saturn's yellowish color comes from ammonia crystals and haze in its upper atmosphere. This planet experiences some of the most extreme weather in the solar system. Winds on Saturn can reach speeds of over 1,800 kilometers per hour, which is even faster than those on Jupiter. Saturn also undergoes periodic massive storms known as Great White Spots. These storm systems can grow so large that they encircle the entire planet. They are believed to occur roughly every 30 Earth years and resemble hurricanes, although they are far larger and more powerful. Saturn's rings are its most defining feature and form the most extensive and complex ring system in the solar system. The rings are composed mainly of ice particles, along with dust and rocky debris. These particles range in size from tiny grains to massive chunks as large as mountains. Scientists believe the rings are relatively young, possibly only about 100 million years old, although their exact origin remains uncertain. Some theories suggest they formed from the remains of a destroyed moon or from captured comets. In addition to its rings, Saturn has a remarkable collection of moons. As of 2023, it has 145 confirmed moons. The largest, Titan, is one of the most fascinating objects in the solar system. Titan is larger than Mercury and is the only moon known to have a dense atmosphere, composed mostly of nitrogen. Its surface features rivers, lakes, and seas of liquid methane, along with mountains and vast plains. Beneath its icy crust, Titan may contain a subsurface ocean of water, making it a leading candidate in the search for extraterrestrial life. Saturn has been explored by several spacecraft. NASA's Pioneer 11 was the first to visit Saturn in 1979. However, the most detailed exploration came from the Cassini mission, which arrived at Saturn in 2004 and spent 13 years studying the planet, its rings, and its moons. In 2017, the Cassini mission ended with a dramatic dive into Saturn's atmosphere, sending back valuable final data as it descended. This mission greatly expanded our understanding of Saturn and its system, leaving a lasting legacy of scientific discoveries that continue to be analyzed today. Uranus is the seventh planet from the Sun and is one of the two ice giants in the solar system, along with Neptune. It has a diameter of about 50,000 kilometers, making it the third largest planet after Jupiter and Saturn. Like the other giant planets, Uranus is composed mainly of hydrogen and helium, but it also contains significant amounts of water, ammonia, and methane. In planetary science, these compounds are referred to as ices, and their presence is what classifies Uranus and Neptune as ice giants, distinguishing them from gas giants. Beneath Uranus's atmosphere, scientists believe there is a mantle made of water, ammonia, and methane ice surrounding a small rocky core. Uranus is unique among the planets in our solar system because of its extreme axial tilt. Its axis is tilted by about 98 degrees, meaning it essentially rotates on its side. This unusual tilt causes one of its poles to face the Sun while the other remains in darkness for half of its orbit. A single day on Uranus lasts about 17 hours. However, because of its tilt, the planet experiences extreme seasonal variations. Each pole receives about 42 Earth years of continuous sunlight followed by 42 years of darkness, since Uranus takes 84 Earth years to complete one orbit around the Sun. The exact cause of this extreme tilt is not fully known, but scientists believe Uranus may have been struck by a large object, possibly a protoplanet, early in its history. This collision could have knocked the planet onto its side. Uranus is also one of the coldest planets in the solar system, with an average temperature of around -224 degrees Celsius. It is even colder than Neptune, despite being closer to the Sun, likely because Uranus produces very little internal heat compared to other giant planets. The planet has a system of faint and narrow rings, discovered in 1977. There are 13 known rings, composed mainly of dark icy particles. These rings are much thinner and darker than Saturn's and are believed to have formed from debris of moons that were shattered by collisions. Uranus is surrounded by 27 known moons, many of which are named after characters from the works of William Shakespeare and Alexander Pope. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are icy worlds that show evidence of past geological activity. Miranda, in particular, has one of the most unusual surfaces in the solar system, featuring giant canyons, steep cliffs, and fractured terrain. Uranus was discovered in 1781 by British astronomer William Herschel, making it the first planet ever discovered using a telescope. At first, it was thought to be a star or a comet before Herschel confirmed its planetary nature. This discovery expanded the known boundaries of the solar system for the first time since ancient history. Despite its significance, Uranus has been visited by only one spacecraft, NASA's Voyager 2, which flew by the planet in 1986. Voyager 2 provided the first and only close-up images of Uranus, its rings, and its moons. The data from this mission greatly improved our understanding of the planet, yet many mysteries remain. No further missions to Uranus are currently planned, but its unique characteristics make it an important target for future exploration. Neptune, the 8th and farthest planet from the Sun in our solar system, is a mysterious and dynamic world. It is the 4th largest planet by diameter, measuring about 49,000 kilometers across, and the 3rd most massive planet after Jupiter and Saturn. Its mass is approximately 17 times that of Earth. Although Neptune is slightly smaller than Uranus in size, it is denser and heavier. The planet is composed mainly of hydrogen and helium, but it also contains significant amounts of ices. Its internal structure consists of a rocky core surrounded by a thick layer of water, ammonia, and methane ice. Despite being so far from the Sun, Neptune produces more internal heat than it receives from solar radiation. Neptune is known for having some of the strongest winds in the entire solar system. Wind speeds can reach up to about 2,100 km per hour, which is even faster than the speed of sound. These powerful winds create massive storms, some comparable in size to Jupiter's Great Red Spot, although Neptune's storms tend to form and disappear more quickly. The most famous of these, the Great Dark Spot, was observed by the Voyager 2 spacecraft during its flyby in 1989. This large dark oval storm was roughly the size of Earth. Neptune takes 165 Earth years to complete one orbit around the Sun, meaning each season lasts over 40 Earth years. These long seasons influence temperature and weather patterns in the planet's upper atmosphere. Even so, Neptune remains extremely cold, with an average temperature of around -214 degrees Celsius. The planet has a faint and incomplete ring system composed mainly of dark particles that are difficult to observe. There are 5 main rings, named after astronomers who made significant contributions to planetary studies. Some of Neptune's rings are believed to be relatively young, possibly formed from debris of moons or comets. Neptune is orbited by 14 known moons. The largest, Triton, is one of the most fascinating moons in the solar system. It is the only large moon that orbits in the opposite direction of its planet's rotation, suggesting that it was captured by Neptune's gravity rather than forming alongside the planet. Triton is extremely cold, with surface temperatures close to -235 degrees Celsius, making it one of the coldest places in the solar system. Beneath its icy crust, Triton may contain a subsurface ocean similar to those suspected on moons like Europa, raising the possibility that it could harbor life. Neptune was the first planet discovered through mathematical prediction rather than direct observation. In 1846, 2 astronomers working independently calculated its position, and its existence was later confirmed through telescopic observation. Despite being the most distant planet from the Sun, Neptune continues to captivate astronomers, offering valuable insights into the nature of ice giants and the outer regions of our solar system. Thank you very much for watching this video. If you enjoyed it, please leave a like and comment below which planet is your favorite. Subscribe if you would like to see more videos like this. Thank you again, and goodbye.